We have studied the matrix representations for operations. Collection of operations, nothing but the group or point group. Whatever the matrices we derived for the different operations, if we collect all matrices, then that will be the representation for whom? Point group. And that we are going to study. What that exactly representation mean? Can we reduce that representation? How to do that? Those things to be what studied. For that, basic necessary is the matrices study. In 3 coordinate system, we derived the matrices. Now those matrices we can derive in 3n coordinates. Means n is a number of atoms. If I consider, say, water as a molecule, 3 atoms are there: oxygen, hydrogen, hydrogen. For each atom 3 coordinates we can consider. So total number of coordinates 9. So 9 dimensional, 9 by 9 matrix we can what prepare for all operations. Similarly, if I consider ammonia molecule, then how many atoms are there? 4 atoms. For each atom 3 coordinates. 3 into 4. 12 coordinate system we can establish. Similarly, if I consider methane molecule, then for that how many atoms are there? 15 coordinate system we can establish. 15 by 15 matrices may what possible. We are not going to discuss those large matrices in detail, but at least for C2V point group, we will obtain those matrices. Means what exactly happening in the C2V point group? For example, say water that I discuss with you. Let me consider this is hydrogen 1 and it is hydrogen 2 and here is oxygen. While establishing matrices, you should know the coordinate aspect. See, x, y, z coordinate. This is the first atom I am considering. x1, y1, z1, 3 coordinates are there. What is the direction of the coordinates? That is a positive y direction towards you, positive x direction towards your right side, and positive z, that is towards upside. As like 3 coordinates are there for this atom, that's a hydrogen atom. Like a second atom in the molecule, that's oxygen. 3 coordinates will be there. Here x1, y1, z1. x2, y2, z2. Similarly, third atom in the molecule, that's the second hydrogen. So 3 coordinate system will be there. x3, y3, z3. What happens for those 3 coordinate system? That we have to find out. If I perform identity, then there will be no change, so you will understand. But if I perform C2 operation, then whatever the x coordinate is there, means which is towards your right side, after rotation, when I rotate that x coordinate will be pointing to your left side. So x1 will become minus x3. Similarly, the y coordinate, if I talk, is origin position. Y coordinate positive is towards you. It's a y1 coordinate. After rotation of 180 degree, that y coordinate will point towards me. And here it was a third atom, no? So y3 was there. So y1 will convert to minus y3. And what about z1? Z1 was positive. After rotation also it will remain positive. So Z1 simply will convert to Z3 because atom position is changed. What about oxygen? That we already discussed. After rotation of 180 degree, X2 will become minus X2. Y2, second atom therefore. Y2 will become minus Y2 and Z2 will remain as it is. Only for hydrogens position is changed. So x1 is converted not minus x1, minus x3. Y1 is going to convert to not minus y1, minus y3. And z1 is converting simply to z3. So such convergence you have to imagine. For that proper operation you have to perform. Now shortly I inform you about the molecular plane. When I perform the operation through the molecular plane, then plane is xz plane. So who is not there? Y is not there. So y coordinate will change. Whose? For this atom. Atom position is not going to change. So x1 will remain x1. Y1 will become minus y1. Z1 will remain z1. Y2 will become minus y2. Y3 will become minus y3. Other things will remain same. If I consider sigma yz plane, a plane perpendicular to the molecule, in yz, who is not there? X is not there. So x coordinate will be what? Negative. For central oxygen, okay, it is not changing place. If it is not changing place, then you can just say x2 becomes minus x2. But these hydrogens will change. Atom number 1 will come to the position of atom number 3 in the molecule. And atom 3 will come to the position of atom number 1. So what will happen for that x1? x1 will become minus x3. And what about x3? x3 will become minus x1. So in detail, The discussion is given there and the establishment of 9 by 9 square matrix is done. But those matrices become so huge, representation becomes tedious. Then one way out is there. We can find character for the matrix. What is character? Summation of diagonal elements of the matrix. And that character is enough for us to describe the chemical aspects. Therefore, I was emphasizing while establishing matrices, remember the character, understand the point, character. Character of identity we say as dimension. So we can get the summation of those diagonal elements and we can get representation. Various representations are possible. Representation always remains with dimension. What is dimension? Character of identity. We can reduce it with other representations which are with smaller dimension. Then original representation can be considered as reducible representation. And whatever the new representations are obtained, if we could not reduce them further, then those will be irreducible representation. So how to obtain reducible representation, how to obtain irreducible representation, that we are going to study. But in this video, you are going to learn what exactly reducible and irreducible representation mean. Various examples that I am going to discuss. We are aware that point group is a collection of symmetry operations. And symmetry operations can be represented by means of matrices. We have studied that in detail. For example, C2V point group has 4 operations. Visually, identity, C2, sigma xz and sigma yz. For each operation, separate matrix possible. And all 4 possible matrices are represented here. What are those matrices? Matrices are the representations of operations. Similarly, one more point group, C3V, which is a collection of 6 operations, visually, identity, C31, C32, sigma xz, as a sigma I am considering, sigma dash and sigma double dash. And for each operations we have derived the matrices, and whatever the matrices represented for those operations are representations of those operations. Since point group is made up of operations, or point group is a collection of operations, and operation can be represented by matrices, collection of all those operations is nothing but representation of that point group. For example, by trivial symbol gamma, that's a capital gamma, I represented 4 matrices. Set of 4 matrices representing respective operations is called representation for that group. Here C2V is a point group, so whichever 4 operations are there, those 4 operations represented by means of 4 matrices, and collection of those 4 matrices is a representation for C2V point group. Likewise, collection of matrices of all 6 operations is a representation for C3V point group. So by red color, whatever the gamma symbol is represented, that is a label for representation of all collected 6 matrices. These representations remains with dimension. 3 by 3 matrices are there, so all are 3-dimensional representation. We can reduce one representation into representations of lower dimension. If we could reduce that, then that representation can be said as reducible representation. And if you could not reduce it further, then that representation will be irreducible representation. So let us discuss a C2V point group and its representation. Let us see whether we can reduce it further or not. If you observe this representation gamma, which is a 3-dimensional representation which encompasses x, y and z as a coordinates, is made up of diagonal matrices, and those matrices we can divide in further small blocks. For example, the first element of each matrix, if I consider it is A11, means first element of first row and first element of first column. A11 of each matrix is a separate block, and we can remove all those blocks from that representation to prepare new representation, and that new representation will be irreducible representation, and this representation whatever is there will be reducible representation. Why this representation will be reducible? Because it has dimension 3, and now new whichever the representation will be there will be with dimension 1, and dimension 1 further we can't reduce, so it is what? Irreducible representation, or whatever the matrices are there, those we cannot reduce further. Say for example, I am just collecting one element from each matrix, which is a representation of x coordinate. So collection of all x coordinate, I am labeling just that representation as gamma x. 1, minus 1, 1, minus 1. It is a matrices. All four separate four matrices I got. Collection of those matrices which have dimension 1 is irreducible representation. And what is the label for that irreducible representation? Gamma x. Similarly, you will understand representation of two element from each matrix as gamma y, because those represents y coordinates. Four separate matrices, one matrix 1, other matrix with minus 1 as element, third matrix with minus 1 as element, fourth matrix with 1 as element. Collection of all those four matrices is a new representation with dimension 1, and it is irreducible representation labeled as gamma y. I am sure now you will understand collection of all z coordinates 1, 1, 1, 1, and representation is gamma z. Means whatever the first gamma representation is there, which is with 3 dimension, we could reduce it in further 3 small set of matrices, gamma x, gamma y, gamma z. What is gamma? Reducible representation. And what are gamma x, gamma y and gamma z? Irreducible representations. Are you understanding concept of reducible and irreducible? Let us understand it by means of further example. Observe neatly this representation for C3V point group. You will find identity and sigma, these matrices are of one category. Means C2V point group, there we have studied such kind of representations. C31, C32, sigma dash and sigma double dash, these matrices are of other category. Now we can't separate them. We have to understand it as a collection. We have to understand it as a set, and representation of this set is nothing but our representation. We have to reduce it now. Suppose if I consider as was for C2 point group only A11, then C31, C32, sigma dash and sigma double dash, their other elements we are not giving justice. So that will not be the proper reduction. But if I consider two elements of the first two rows and two elements of the first two columns, means again 2 by 2 square matrix, means what I want to say, A11, A12, A21, A22, these four elements, four numbers from each matrix, then every matrix will get the justice for its representation. Means what I am doing here, I am not representing one by one matrix. Here I am not representing one by one means one dimensional matrix. Here 2 by 2 matrix it will be. That's a two-dimensional matrix. X and Y, these coordinates will be involved to fulfill those two dimensions. Means what I want to say, 2 by 2 is a one kind of the set we can arrange, and at last whatever the last Z coordinating representing numbers are there, I will represent them as I did for the C2V point group. So that will be the one-dimensional representation. So whatever the three-dimensional representation is here, gamma, that I can reduce into See now, these two representation, gamma xy, two-dimensional representations, where A11, A12, A21, A22 elements from each matrices are considered, and gamma z, where A33 element of each matrices is considered. So gamma xy and gamma z are our irreducible representations. We cannot reduce gamma xy further. So that is our irreducible representation. What about gamma? I can say it's a gamma xyz. That is a reducible representation. So here emphasis was to make you concept clear about reducible representations and irreducible representations. Whatever the representations we are here, those are three-dimensional representations because we considered molecule in xyz coordinate and then we established the matrix. Other ways are there to establish matrix. Let us attempt it. I'll explain it for C2V point group. In C2V point group, example say water. Three atoms are there. What can I do? For each atom, I can consider three coordinate representation. So for three atoms, representation will be 3 into 3, 9 coordinate representation. Matrix which can be resulted by that consideration will be 9 by 9 matrix. Let us see that 9-dimensional matrix, how to reproduce. In next part. Now as a homework, I have a question to you. In C3 point group, sigma V, three operations are there in that class. What is a character for sigma V in three-dimensional reducible representation? Write just that number in comment box.